Hey, I'm Joe. So I'm working on my 1979 Honda CBX again today, and I've been working through a bunch of the wiring, a lot of the wiring that has to go up front inside the headlight bucket, and the last thing I need to wire up, at least the last big component, is the speed sensor. So these are the gauges that I'm using on my CBX Cafe Racer build. So I have the speedometer over on the left, and then I have the tach on the right. So I will show you what these look like real quick. So I'm going to turn it on. You can see that the gauges turn on. And then the wiring that I completed is now I've got these controls that when I press, I can go through the mode on the left side, and then the bottom allows me to set. So this had an optional remote in that I was able to wire directly into. That way I'm using all the functionality of the right control, which is fantastic. So this is the speed sensor. So the way that the instructions describe is having this sensor right here contact a ferrous metal component somewhere that moves on the bike. It recommends using something like one of these brake bolts. So to test real quick if this is a ferrous metal is to just take a magnet. Ferrous is anything like iron. You can see my brake rotor is magnetic, but the entire thing is magnetic, so we can't use that. It looks like these are not magnetic, but these bolts are. One of the things that I was thinking was I could mount it here and then use one of these existing brackets, which these typically hold a front fender, which I haven't designed for this bike yet, but I would like to. So I could go off of this and then I have to run the wire up. But I'd like to keep the front end as clean as I can. So I was looking at the back, and they do provide a wire that is long enough to run from the back to the front gauge. These bolts that are holding this rotor on, luckily, are magnetic as well, right? So after looking at the front, I think the back may actually be a better way. There's a lot more going on, so it will look, I think, a little bit cleaner. You won't notice the wires as much. And something else that I haven't wired as well is a light for the rear license plate. Legally, I believe you're supposed to have these, and because it's mounted over to the side, I don't have a light that's coming down. But if I'm wiring a light here, I could easily put the speed sensor against this bolt, which is just holding this arm for the rear brake, and I could run this down so that it contacts and mount the sensor here. So I'd have one wire running up here, and I could have the other wire running up here as well, and then I could run them together to the bike. And that's probably the best way to do it. That way, like I said, I can keep the front clean. I'm going to take measurements and then 3D print a bracket so that I can mount the speed sensor here. So I'd like it to go around this bolt, and then it will go down, and then I'll mount it so that I've got, I think it's a 1 to 3 millimeter clearance, which isn't a lot. We obviously need to make sure the wire's not going to hit anything, and I think we can keep it clear, which will be easy. This isn't too far of a run, whereas the front, it's a much longer run down that front fork. So I'll take some measurements here, and then I'll do a couple test prints to see if I can get this in a place where I'm happy with how it's mounted. So I'm gonna be using my digital calipers. This will make the measuring easy. So I'm just gonna grab this washer. It's on this bolt. So this bolt hole, so I need 8.5 millimeters. And then I need to measure down. So it looks like from the center of this hole, so it goes over the middle of that bolt. Let's do from the center of this hole down 123 millimeters long. 5 millimeters in, I will be right up against. We'll try 4. So I have 7 millimeters here. So I think I have most of these calculations. So check the sizing of this screw. Looks like if I plug this into the M3.5, that is the size screw that I need. It looks like I have a bunch of different length M3s. So it looks like this one is about the same length. So I'm probably already using an 8 millimeter. So if I did another 4 or 8 millimeters, Yeah, another 4 millimeters looks like it would be a good thickness. So we'll do that. We'll make it 4 millimeters thick, and that will allow us to use this screw. All right, so let's design this bracket. So I've got Fusion 360 open, that's what I'm using. And I'm going to select the face. Let's start by making the end that connects to the bolt up top. So this needs to be, we said 13 millimeters here. And then I will scroll in 13 millimeters, zooming in a little bit. And then let's make the length of this. So we said this needed to be 123 millimeters long, and that gets us down to the midpoint. And then we've got our speed sensor, which we probably want to go a little bit further. So the speed sensor itself, I'm measuring this real quick. From the middle, probably want to extend it another, let's say 4 millimeters. To that 123 is 127, which is there. And then there is a point at which this needs to get thinner. So let's just do 20 millimeters. From the end, another construction line. Let's come back and do 20 millimeters. And then we want to come into the size of the part, which we said 9 millimeters would work. So we need to take 4 millimeters off. So we need to come in 2. Let's change this back to actual line. So we'll do this line comes to here. And then this line is coming in 2 on each side, and then we'll come all the way down here. And then we'll come over 9. And then we'll come back to here. And we'll come down 2. And then we'll come over to here. So let's finish this first sketch. All right, so it looks like we have the outline. All right, so next thing we want to do is let's make this thick enough. So we wanted this 2.5 millimeters, so let's do an extrude. Let's do 2.5, like that. And then we need to make a hole right here. So let's create a hole, and let's get the center line, and let's do a construction line here. And what we should have done is actually extend this out a little bit. So we probably should have made this a little bit longer because I was measuring from bolt to bolt. I probably should have given a couple millimeters on this end. So let's do this. Let's come out. Let's add, we've got about 5 millimeters, so that's what we should come out. Right there. We'll finish this sketch. We'll extrude the same way we did before. We'll do 2.5 there. All right, so now we can make this hole. So it's an 8 millimeter hole. The 4 plus the 5, so it will be coming over 9, which is right there. And then we will create a circle, which we said was 8 millimeters. And we'll take it off construction, and we'll finish this sketch. And then what we can do is just reverse this extrude, and this will hollow it out for us. Like that. All right, so that is one end. Now what we also needed to do was we needed a hole down here, but we also needed this offset just a bit. We need this to shift up. Let's try right here. And then I'm going to go back to extrude. Let's extrude this up. Let's say we come off 2 millimeters and hit OK. What we could also do to help add a little taper, we could do it like this and come all the way out here. Let's finish drawing these lines. This may make the extrude easier. Do this. Now let's try doing the extrude here and here. And if we cut this all the way like that, that will give us a shape like this. And we could also do something similar here. I can create a line here. This does not need to be perfect. And then we'll do the extrude. Like this. All right, so now we have almost everything that looks good. I missed this piece here. And this was just an issue with this sketch. What I should have done is take this here, and then we'll finish sketch. And that should fix it. Perfect. The last thing is we need to put the hole. We'll do 16. So 16 millimeters. Do this from the top. Make sure it's a construction line. So yes, this was 9, so we want 4.5, which is there. And then we'll do 16, which is right there. And then we'll do the circle, take off construction. And this circle needs to be 3 millimeters. We'll do finish, and then we'll run the extrude through this. Make the hole. Do OK. And this should be our design piece. Let's save this. We'll say this is the finished bracket. And then let's export as a 3MF. We'll call this version 1. And then we'll open up the Prusa slicer. Let's import that bracket. And then I will set supports to on build plate, because I'm sure it's going to need supports because this end is raised. We'll do slice now. So it looks like it'll take a total of 15 minutes to print. I'm going to hit send to connect. It's going to send it to my 3D printer, and then I will hit confirm. And it just uploaded. So the print is on the printer. So I'm going to go in, I'm going to make sure it's set to filament 1, which is PETG. I'm going to click print, and then it's going to start. All right, so the piece looks done. Let's remove it. And then we can do a bit of testing to see if we got the measurements correct. So I've made a couple more changes. So you can see I went through a couple revisions. So this was the initial one. You can see how this is not real rigid. So the next one was a little bit stronger. I also added a place where I can run the cable because I want that away from the brake rotor. Then I moved the sensor closer to the brake, which I needed. And then you can see on my final design, I needed to raise it up just a little bit more so that it was closer. So now I should be within that 1 to 3 millimeters. And then I added these slits, and this allows me to zip tie the wire to the back, just to ensure that the cable doesn't move. And I added a couple holes in here just to make it a little bit stronger, because when you're 3D printing, it'll help build up the perimeter walls. So this should be the right design for what I need. So now I just need to mount this on the bike. Now, something else that I added to this bracket was, you can see there is a little lip right here. This is so it pushes up against the bike so that it doesn't flex as much. So the sensor is going to mount here. I'm going to get it in position. And I'm going to take the nut and tighten this down. Just going to do hand tight for right now. You can see that the speed sensor is the right distance from the bolt, so it needs to be real close, but that should work. All right, that's it for today. I still need to do the actual wiring up of the sensor, but I don't have a way to test it right now because the bike I haven't started yet. So once we get to that point, I can actually test to make sure that the speedometer and the tachometer are both working the way they're supposed to. All right, thanks for watching. If you want to get notifications when I release new videos, just hit subscribe.